Hi everyone and welcome back to the channel. And today in the Learning FreeCAD For Beginners series, we're going to be looking at two lofting workflows. So we're going to be looking at a part design and a part lofting workflow. The first one is in the part design, and we're going to be creating reinforcements via a loft. So these parts here are reinforcing this object. So if we had a hole, so say with a wheel in here, these will be our reinforcements. In our other workflow, this one here, which is a part workflow, we're lofting to a surface. So we can know we can loft to a point or loft to a profile. We're actually using a surface in our lofting workflow. And this is good for when you have a loft, but the end surface is not a flat profile. You want more control of the end of the loft using regular surfacing techniques within the surface workbench. So I hope you're enjoying these videos. Let's have a look at these techniques.
If you like what you're seeing, please subscribe to the site. I also have a Ko-Fi or a coffee site that you can donate to if you so desire, and that's at ko-fi.com/MANG0. I also run a Patreon where you can subscribe and get extra content, and that's at www.patreon.com/MangoJellySolutions. Any money that's kindly donated will be used to expand the channel.
So for this first workflow, we're going to be using the part design. Create a new body, and I'm going to create a new sketch upon the XY plane. So looking down on the object. We're going to create a very simple structure using the endpoint and rim point arc. Coming in here, we're not going to touch this line, otherwise we're going to get tangency on that line. So I'm going to make sure I'm well away from it. I'm going to hit escape to get the mouse pointer back and add some lines. So just come in up here, add some lines this way. Hit escape and take this arc and this line and just make them tangent. Okay, and the same with this one. So we've got tangency across there, and we've got endpoint tangency applied. We'll just close the sketch with a straight line going across here. Hit escape and take this point and make them coincident. So we have this structure. It's going to add these 2 points and this line with symmetry. I'm going to pull this out. So we have this structure. I'm going to hit close, and I'm going to pad this by about 20 millimeters. We've already got it selected, so pad it by about 20 millimeters. And then we're going to sketch upon this face. So I'm going to select this face, and I'm going to create a sketch. The reason why I'm selecting the face and creating the sketch on there is because I'm going to show you something regarding a problem that may happen when you go and add this feature. So again, I'm going to make a very similar sketch. Coming out, I could have used the polyline to save myself a bit of time, which I should have done, but that's okay. And make those coincident. And take these two. We need tangency. Okay, that, and these two with tangency as well. You can uncheck this if you want. Saves you getting those messages come up. So we have this now. And finally these 2 points and this line with symmetry. Close that. This sketch has the support of this face, pad face 6, and flat face on there. Let's pad that, and we'll pad this by 15 millimeters. Now what I want to do is I'm going to have a hole in here, and I'm going to fit, say, a wheel on here. Let's say this was part of the base of the chair where a wheel sits in here. So we need some supporting geometry to hold this, so some supporting material to go in here. To do that, I'm going to make a loft between this face and this face. But I can't do this at the moment because these are a bit too big. I want something a bit smaller in here. To make the loft as we are, just click on that face and use the additive loft, and you can see that face has been added. So we can loft faces, add section, and then click on the other face. And that lofts between those two, like so. If we hit OK, we can see we've got this support now that will strengthen this part of the object. But I want this smaller. To do that, I'm just going to delete that loft and bring back the pad, this one here, and I'm going to go in to the base pad. So I'm going to come back to the very first pad we did and come into the sketch. Now I'm going to add some geometry in here that's going to break my operations below this pad. So I'm going to split this edge using the split tool, which is this one here, split edge. Sketch, sketch geometry, and split edge. So we're going to split this edge just by clicking on this arc, and we can make some symmetry across these two with the vertical axis to make that symmetrical, and hit close. Now if we look on the left hand side, we can see a problem. This sketch has now got an exclamation mark on it, and it says no planar face in attached engine. So it's given us an unusual error. The reason is because we've changed the underlying geometry. So we've added more edges, and if we look, this says pad face 6. Remember, this pad is still visible. So what's this pad, this face here? If we hover over it, we can see that's pad face 8. So our face has become renamed because we've added more faces on here. This is really easy to solve. All we have to do is come to the sketch where the support is. We just click on it and just clear that support and hit OK. When we click off, it recalculates and our sketch is now fine. We can remap that sketch if we want, but our pad is fine now. We've got no errors. We can leave it as it is, or we can remap it. So let's bring back the original pad and click on this sketch, which I'm going to remap. Click the map mode and select this face and hit OK. Click off. It's got ticked by the sketch saying it needs recomputing. Edit, refresh, and everything's OK. So bring back the pad and we can see that sitting there. I'm going to create another split like this one on this side. We could use this if we wanted just to loft between these two faces, but I'm going to do the same on this side. We've got no operations in front of it, so we're going to be OK. Let's double click that and add the split. And we just split these two and take this point, and the vertical axis, and just use symmetry across those. Hit close. We now got these two faces. The sketch is still visible, so we can click on that, press the space bar if we want to, and we can add the loft. To do that, again, click on the face, additive loft. The face has been added, and then we just add a section and click on the other face. And we can see we've lofted between those and hit OK. So we created that feature there. We could even delete the additive loft, click on the pad, bring it back by pressing the space bar and say add a loft between these two and these two. So click on that face, click the loft, add section. That's lofted between those two. Hit OK. And we can do the same on the other side. So click one, loft, add section, and click on the other face, and OK. So we've created that loft between there, and we've got a nice sturdy support if we're going to add a hole here for, say, a wheel or something. For our next loft workflow, we're going to be using the part workbench. The reason why we're using the part workbench is because it's very versatile and very flexible with the different profiles that you can use with your lofting. For instance, rather than just using sketches and faces, we can use surfaces, vertices, edges, etc. in there. We're going to be using a loft to a surface workflow. And this comes in handy if we want to close the loft, but we don't want to close the loft to a point. We actually want to surface the closure so it's a feature in itself. I'm going to come over to the sketcher and first create the closing surface. I'm going to do something simple. So I'm going to go along the XY plane and I'm going to use a slot geometry in here. Just a basic slot geometry. And we're going to constrain this down as well. It doesn't matter what constraints you put in here, I'm just going to constrain it down and make this symmetrical to the center. So this is a profile in itself, but we're going to use this in the surface workbench. I need to add some kind of surface on top of here. Now I'm just going to go for an oval dome surface. Before I do that, let's make the profiles for the loft. I'm just going to duplicate up this sketch using duplicate section a couple of times. And we're going to transform them using the placement position along the z-axis. And we're going to go -10. And this one's going to be -20. Let's amend some of these profiles to allow for the loft. So for instance, this one, we're just going to set the length for 100 millimeters and a radius of 30 millimeters. Let's close that and select the next one. This one here. Radius of 25 and a length of 90. And close that. So we have some profiles to loft against. I'm going to hide these profiles, these two here, pressing the spacebar. And this is going to be my top profile. So this one is going to be my surface profile. Now I need to think about what my surface is going to look like. We're going to be using the surface workbench to create that. And this is going to be our base shape. And then we're going to deform the surface upwards in an arc. For that we need some supporting geometry. And this will support the surface as a constraint. So the first one I'm going to do is create some cross pieces. So some cross arcs here using these points as the attachment. Now we went through the attachment modes, OXY, OZX, etc. in a previous video. And I'm going to use those for this one. But I'm going to talk you through them. So if you haven't seen that video, then we can still do those. Let's come around to the left hand side. And we're going to zoom in. And I'm going to attach to these points here. We can select both these points. You hold it down the control key. So I've selected both of those. And we can create a new sketch and select the right attachment. So O is the origin of your new sketch. So we've got two reference points. O is the origin, which we attach to the first one we selected. So the first reference point. The second one we selected, which is over here, will be the second point. So these are the axes of the sketch. So the origin is going to be attached to point 1, and the next one, the X or the Y or the Z, is going to be attached to point 2. So I'm going to go OXY and hit OK. And you can see how that's placed me. It's attached me from this point to this point. But we are round the wrong way. We're actually looking down on this where we need to be on the side. We can change that by changing the rotation. So you can see the origins here. My X of the sketch runs this way and the Y runs this way. It's a bit of an advanced attachment mode, but it's very powerful. So I can add my sketch in here. The curve, and we'll pull in this point here. Hit escape and use a coincident constraint across those, and then we can rotate this over by selecting the sketch, coming down to the data. It's now attached, so we look at the attachment, going to the attachment, coming to the angle, and we need to change the axis as well. So I'm going to put 90 degrees on this angle. You can see what's happened. It's gone around this way. When I click off, the constraint will kick in. So remember, it's constrained to this point here. Let's change the axis. I'll come into the axis. At the moment it's around the Z, so 0 that, and place a 1 in the X and click off. And now that's in the right position. And rename that to profile. So profile 1. I'm going to take this profile and duplicate it. Uncheck the surface profile because we don't want that, we just want one profile, and hit OK. Now we've got the profile 2. It's in the same position. So come into the map mode. Now I'm going to come into this vertex here and delete the contents. So we can delete that and delete the other one. So now we're back to the start. Click reference 1, select the other vertex, click reference 2 and select the other vertex, which is behind this one. So really, if we look at this, we don't actually need to select that because translate origin was enough. Let's hit OK. So we've got those two in there. Now we can add another arc that goes this way. So we're controlling the surface at 3 points. So 1, 2, and a third that goes this way. Let's come around to the front and add the arc in. So this is going to be on the XZ plane. So new sketch along the XZ plane. Okay, that. I'm going to pull in some geometry. So I'm going to pull in this arc to get this point and this one. And also these arcs as well to get the top points. I can use these to my advantage now. So I'm going to create a couple of arcs connecting up. So our first one, our second, and our third. Got the auto constraints on, so when I hover over these we get the auto constraint. And make sure that these arcs are tangent as well, so using the tangency in OK and the tangency here as well, so nice and tangent. That means if this arc changes, the others will as well. For completeness, if we wanted to, we can pull back the other profiles. So the ones that we made invisible, let's bring these back. And I'm going to add some construction geometry because we can keep this tangent with these profiles as well. So we get a nice transition. This is depending on your application. So take a line, connect the line up to this point, coincident constraint, and place a line, say down here. We next take this line and this arc and make those tangent. And OK. If I move this line, we get the tangency of our surface moving. So I can place this, say, on here and control the rest of our shape. May need to zoom out a bit. And if we have a problem, then we may need to pull in, say, this arc, come in, make this point and this point coincident, and we get our arc shape here. If we want to, we can remove this arc and add more arcs in. And making those tangent. So it's totally up to you. Just gives us more control over this surface. Once I'm happy, you may want to change this to construction geometry so it doesn't show up. So this is blue now. Come over to the task and hit close. So we've got this arc in here that we can now control. Let's change this to profile 3 Let's create our surface. Go into the surface workbench and create a fill-in surface. Add edge, and we want to add the top edges in sequence. And finally this one, like so. And then we add the constraints. So come down to edge constraints, and we start to add the edge constraints. So add edge, and I'm going to add this one first. If it vanishes, we can come underneath and select line from underneath, like so. And this one, so you can see how that's deformed up against that arc. And then we add the other arcs as well. This controls our surface. So we get this nice surface in here. Because it's all attached to these arcs, so there's a crossover point, we get a nice clean surface. If we OK that, we can see the other options that we have to make this even better. So if we look at the surface on the left hand side, we can see the options available to make this a better surface. I'm first going to come out to File and Save to save this project. The reason why I've done this is because some of these options, if we push them too far, it can hang up the computer. So the first is the degree. If we change the degree, this is the starting degree of this surface. So you can see how that's changed there. Lowest is 2, and we can increase this up and we can see the degrees of the surface changing. Push it too far and we start to get problems. So it's the starting degree of how this surface curves up. Obviously, if we've got restrictions via constraints like we have in here, then it's going to affect the degree and how much of an effect that has on your surface. The next one along is the points on curve. So these are the constraints. And we can increase this to say 20. And we'll get more points on this edge. If I bring this down to say 2, you see how the surface has taken effect there. We look from the side and we've got these curves. You can see that we haven't got enough points on these curves going around. Again, watch out for putting this too high because it can hang up your computer. Set this back to 15 and it'll look fine with the 15. The iterations is the algorithm. So this is approximation algorithm that used for the NURB surface that's placed across there. All the values that you see along here changes the tolerance of that algorithm. There is not much documentation around these values in the FreeCAD wiki, so it takes a bit of experimentation to get that correct. If I lower the iterations to say 1, you can see that we've got a less defined surface and the number of points have moved away from this curve. So now if we up the number of points, say 30, you can see they've been placed back on there. I'm going to set this back to 15 and the iterations to 2. To clean this up even further, we can go to the View tab. So make sure it's selected, go to the View tab, and we look at the deviation. So this is the accuracy of that polygon. And drop this to 0.05. And you can see an instant effect in there, and it's cleaned up that surface. Now we can get into the lofting. To do that, I'm going to come over to the Part Workbench, and I'm going to use the Loft feature in here. This is quite flexible in the Part Workbench because we can loft between profiles and a surface. So let's click that feature for the loft, and we can select our sketches. So we want this sketch here. This is where naming them comes in handy. So sketch 2, we can see it highlighted in green. The next one is sketch 1, and then last of all the surface. Now it's up to you if you want to create a solid. Click create a solid, OK. And we've lofted through from the surface all the way through the loft. We can see the tangency on this side, and if we want to change any of this we can by just coming back into those surface profiles. So I'm just going to hide, if I come into the loft, I'm just going to hide the surface sketches that go around. And we'll come up, I'm pressing the spacebar to hide these. And I may hide these profile ones, like so, and this surface profile that goes around here, and just leave this line on top. And let's go to that one and change this. So I'm going to make another line that connects up here, downwards. Taking these two, make them tangent. Okay, that. Make this one construction, and we can move that into place. So we may have to move these points to decide where that's going to go. So something like that, and hit close. And we get a nice tangent curve there. I can click on that. Finally, I can click on that sketch and press the spacebar. And we have our loft to surface. So before we finish this tutorial, one thing to remember that I nearly forgot is that this loft is totally separate from this surface. So we need to connect these together. We could hide the loft and then come back over to the surface workbench and surface at the bottom of this. Come over to the surface and use a fill-in surface, add an edge and work our way around the edges. So you'll remember the last one, hit OK, and then come over to the part workbench. Make sure both are selected. Go to part, compound, make compounds so they're both connected together but they're not booleaned into each other, and then select the compound, part, convert to solid. We have a solid shape now. I can hide the original compound, and I know that's solid because if I add the sphere and then take the one I want to keep, the one I want to remove, and do a cut on that, you can see that's being removed. Let's Control Z that and delete the sphere. Now I can bring back my loft and boolean these both together with the union or part. Come down to the boolean and union. We created a single fusion which is still a solid. And if I add the sphere, transform, I can take the sphere away from the main body with a cut, like so. This edge is just the edge of the sphere. If I rotate the sphere around, then that will remove that from there. The other option, if I wind this back a bit and go back to the compound and delete that, so we've got the surface, and let's delete that surface from there, and we've got the original surface, so we can see that needs surfacing. We can bring in the loft. At the moment the loft is solid, so we'll take the loft, come back to the solid on the data tab with the loft, set that to false. Therefore we get this continuous shell that goes around here with these two parts. We'll surface this, open the surface workbench using the fill-in, add the edges, working our way around again. Now we've got three surfaces, well, two surfaces in the loft. So we've got a surface inside the loft, control click the other loft, and control click the surface. And well, we need to be in the part workbench, and we need to compound them together. So we can use the compound tool in the toolbar, or part, compound, make compound. And finally, take that compound part, convert to solid. The original compound, press the spacebar to hide it, and we have a solid left over. Now we'll just double check with our sphere, transform it, OK, one we want to keep, one we want to remove, and we do the cut. And we can see that's taken that sphere away from the side. The other thing is that because we created the compound solid, that's not parametric, so any changes won't affect the solid. To make it parametric, let's bring back the compound. We can use the curves workbench. So I'm just going to delete that compound, open up the loft so I've got the surfaces. The curves workbench is an additional workbench that can be found on the Tools add-on manager. And we've got something in here called Parametric Solid. So we can take all the surfaces, control click on them all, like so. Go up to the MISC and Parametric Solid. At the moment that's made a shell. So you can see shape status is a shell. Let's delete that and go back to the part and create a compound between these. So I'm control selecting them. Compound, curves workbench, click the compound, MISC, parametric solid, and now that's a solid. So if you compound it first, then you get the solid. If you don't, you'll get a shell. Obviously the solid will allow you to build in it, but you may want a shell instead of a solid. It's totally up to you. I hope that's answered those questions. I hope you find an application for that to make your life a lot easier when you're creating your models. Look forward to seeing you in the next video.
If you like what you're seeing, please subscribe to the site. I also have a Ko-Fi or a coffee site that you can donate to if you so desire, and that's at ko-fi.com/MANG0. I also run a Patreon where you can subscribe and get extra content, and that's at www.patreon.com/MangoJellySolutions. Any money that's kindly donated will be used to expand the channel. Thanks a lot for watching and subscribing, and I'll see you again soon.